Okay, so we've talked about ratios and proportions, and this is more of an application lesson on what we do with this. And we can use ratios to determine the dimensions of something that is maybe too big or too inconvenient for us to measure. So say I have an example here. I have a tower, and I want to know how high this tower is. Okay? And I don't know what it is, so I'm going to call it H. And I do know, though, that the sun is casting a shadow. Silly thing. And the shadow out here is 27.6 feet long. Can measure the shadow, obviously. Okay. I also know that there's a person here who is 6 feet tall. And his shadow is 1.2 feet. Okay, so I can set up a ratio to figure out what H is. And to do that, then we have H over 27.6 equals 6. I'm going to put the height first and the length of the shadow underneath it. And then that gives me, if I do the cross multiplication, 27.6 times 6 divided by 1.2. And I say that H is 138 feet. So the tower is 138 feet tall. Okay. Another way of doing this, we can do it things that are horizontal. So let's say we have here a dimension here, and we have a lake. And we've measured some triangles around the lake, and we do know that this distance here is 12 meters. And I also know that this side here of this triangle, from there to that point, is 25 meters. Okay? And then this long distance here is 60 meters. And without measuring it, we want to know what is the distance at the end of the big triangle. So again, we can set it, since we know that the triangle is proportional, okay, we can set up another ratio. So we would have x over 60 is equal to 12 over 25. And if we do the math, 12 times 60 divided by 25. And we would have that x is equal to 28.8 meters. Okay, so just a couple of quick examples, and that should set us up for problems in class, and I'll see you then.